Thank you so much. Thank you for coming. I have a question for you. What was the first database that you tried, or like the first database you heard of? There are actually many databases nowadays, like a lot of popular databases, a lot of interesting databases, but yes, most likely the answer would be Postgres or MySQL. And those were my first two databases as well. In fact, those two databases were enough for my first 5 years of career in software engineering. Like all the projects I worked for used either one or another. But then one day I joined a new project, and that project, like it was in 2013, that project was working with real estate data. It was like a real estate website where you post advertisement. For example, you want to sell a house, or you want to rent out a flat, or lease an office, you can post an advertisement. You can be like an individual, or you can be an agency, and you want to like advertise it so people can use it, can find what they're looking for. And the next question is how the data for such advertisements would look like. That project used MySQL, and that's how a table with advertisements looked like. I mean, it had much more columns than how many I can put on the screen. What is interesting about this data, most of the columns for each individual row were nulls, because you can imagine, like, an advertisement to sell a house looks completely different from advertisement to rent a flat. So, in fact, we have like plenty of rows, with very different data, with a lot of nulls. And also, every time when we want to add a new property to an advertisement, we have to call alter table to like add something new here, and it already has a lot of columns. Luckily, when I joined that project, it was a moment when redesign was like needed, and so we decided to use something else. Back then, we decided to first of all introduce REST API. Again, remember it was 2013, so not a lot of applications was like backend plus frontend. And so, of course, we decided to use some JSON API to return the data. And then we thought, okay, if we return the data in JSON, why can't we just store data as documents? Each advertisement can be a document. And then we just don't need to store the properties that we don't need. Then again, the natural choice was to go with MongoDB. And in case of MongoDB, it's super easy to insert data. And that was a really right choice for us back then. So in case of MongoDB, we have really great work in case of document-oriented approach, in case of document-oriented cases, and that was our story, exactly. Then MongoDB has flexible schema, so we actually don't need to call any alter table commands when we introduce new properties. We just like do it, and that's it. MongoDB has a really nice query language. If you start using it, you get to use it, and then it's like super easy to modify data, to search data, to work with data in any different way. Also, MongoDB has a really nice aggregation framework. Again, if you want some statistics, if you want to do some aggregations, and yeah, there are like plenty of ways how you can do it, and it's very handy. Overall, the story of experience for you as someone who needs drivers is like really nice. For different programming languages, the drivers are easy to use, and overall developer experience is really great. Okay, those were all the wonderful things about MongoDB. Maybe not all, but at least some. And here I have a question. Why nowadays I would be a little bit more careful if I need to choose a document-oriented database? Why I wouldn't actually choose MongoDB? Something happened, and this something is about the license. So before 2018, MongoDB used an open source license, AGPL. In 2018, they introduced their own license, SSPL. There is something interesting about those two licenses, so let's talk about AGPL first. AGPL is like a typical open source license. It says that if you modify MongoDB and you want to run it as a service, you will have to release the modified source code. That's fair enough, right? You like work with like some open source product, you modify something, well, you need to share it to show what was changed. What happened with SSPL? If you offer MongoDB as a service, even if you don't modify it, you are required to release the code that makes your product a service, like everything around it. And what is also important, you need to release it under SSPL license. Let's say I'm a cloud provider, I run MongoDB on Windows. It means I need to release Windows, but can I actually release Windows, especially under SSPL license? Not really. So yeah, that makes it hard. But actually, yeah, here you can say, okay, I'm not a cloud provider, why should I care? I can run MongoDB myself on my own infrastructure, or maybe my infrastructure engineers can run MongoDB for me, like, why should I care? Well, there are at least two reasons. First reason is probably more obvious, it's vendor lock-in. So we love service-based solutions, and we love to run our databases on cloud. And if you want to run MongoDB on cloud, not yourself, there are only a few solutions available. So it's either MongoDB Compass or maybe a couple of alternative solutions from big cloud providers, but nothing else, basically. Still, you might want to say, okay, I know how to run databases in cloud, or my team knows how to run databases in cloud. I don't need anything that is like run by someone else. There is another interesting thing about that license. The definition of as a service is quite tricky and interesting in the SSPL license. The license itself is like TUAG. Specifically, those are like some examples of from the license. Those are examples of what is described as a service. I'm more interested in the last one. So, yeah, if you offer a service that accomplishes for the users the primary purpose of MongoDB, then it is considered that you run MongoDB as a service. That's very tricky, right? Like, for example, let's go back to our story about real estate website. Let's say our website became very popular and we started offering some low-level data to our users, maybe to real estate agencies, in which case this situation will happen for us, in which case MongoDB can say, oh, actually now, for your users, you accomplishes the primary purpose of MongoDB. In fact, there is no guarantee that one day MongoDB will not come after us, especially if you become very popular. So the question is what to do. Like, do you have any alternatives? Luckily, there is FerretDB project, and the main purpose of FerretDB is to bring MongoDB back to open source. So my name is Elena Grahovac. I have 15 years of experience in backend engineering and infrastructure engineering. And last year, I joined FerretDB to help FerretDB achieve that goal to bring MongoDB back to open source. And I want to share our journey, how we do it. Let's start from the idea. So we want an alternative to MongoDB. How could we come up with it, what we need? So we need something that can work with existing MongoDB drivers, because as I said before, MongoDB drivers are really great, and so like, it's really great if you can just reuse them. There are also quite a lot of frameworks and applications that use MongoDB. Again, it's great if you can just offer seamless transition to something new. We want to offer a fair open source license, because that's basically the main reason why we want to build something new. And we don't want to build data storage, because building data storage is a really hard problem, and there are many, many great databases around, so why should we build a new one? We can actually picture it as such a diagram. So we have MongoDB drivers on the left. We have some data storage on the right, like a backend. And we can have FerretDB between them as a stateless proxy that can actually transition MongoDB queries to backend queries, and that can like return the data back. OK, now we have an idea. Let's talk about task definition and implementation. What actually we need to do to implement such an approach? First of all, we need to understand how to store the documents in the storage. And yeah, we need to understand how to query the data, how to query those documents. Sounds simple, like we have only those two tasks. And here, important thing to know is that MongoDB stores data in BSON format. BSON is binary JSON. So what's the difference between BSON and JSON, apart from that it's binary? It has some special like properties. For example, the data, the fields should be key-value pairs that are ordered. In case of JSON, usually we don't talk about ordered fields. Like, well, order doesn't matter. In case of BSON, order matters. And also, there are some additional data types in BSON that don't exist in JSON. Let's think how can we achieve compatibility. How can we store BSON data in JSON? So first of all, we need to understand how to make the order preserved. And secondly, we need to understand how to support those special data types. Those are, again, only two questions that we need to solve. And I have an example how we decided to solve it. So here I have a very tiny BSON document that has two fields. First field is an object ID, but the type that doesn't exist in JSON. And second field is a regular string. In case of JSON, we can represent both fields as just like strings, because like why not? Object ID is not so special, actually. It can be presented as a string. But we also need to store the information about field order and the information about types. So we can introduce like a special field in our JSON object schema where we can store the information about the types and the information about the orders. We can make the schema nested in case of like nested documents. And yeah, it's not a big problem to store data like this. We just need like one special field where we can store all the information. So the second question is how to query the data. OK, now we can store it, how to find it. First approach, that could be probably the easiest approach possible, is to fetch everything from the database, apply some business logic on the application website, and do it. So that's how FerretDB worked initially. We were fetching everything from the backend, and then we were applying the logic given in the query, and then we're giving the results to the requester. Of course, it's very slow. Imagine you need to fetch all the data from the database before you can give it to someone who requested it. So the better approach is to push down to the backend, and yeah, it is possible to push down some queries to the backend. For example, we can use indexes on the backend side, so it will be faster and easier to get the data from there. And also we can transform MongoDB queries to backend queries. Again, there are some cases when it's easy to do it. The next question is, which backend should we choose? So, again, very natural approach. We decided to choose PostgreSQL. Actually, not only, but Postgres was the first very simple step because it's open source. The license is really well. It has a really great supportive community, really huge community of people who know how to run PostgreSQL in many different ways. Also, PostgreSQL is well known for its reliability, so many companies and database administrators know how to run PostgreSQL, what kind of problems you might meet. And PostgreSQL has quite nice JSON compatibility, including ability to index JSON fields and including ability to query JSON fields. So Postgres it is. Okay, it sounds like we solved the problem. We know how to store the data, we will use JSON. We know where to store the data. We choose Postgres. And we kind of know how to query the data too. This is where real life is starting because there are some interesting things in the way how MongoDB works. There are some interesting compatibility challenges we met. I will show you one example. So imagine we want to work with arrays. So we work with documents. Those documents store arrays. In our case, we have 3 arrays, elements 1, 2, elements 3, 4, and an empty array. Let's say we insert 3 documents to the database, and each document has a field v where we store those 3 arrays. And we want to get the data that we just stored. We want to sort it by field v. How the results should look like. So the empty array will be first. Then we have an array of elements 1, 2, and then an array of elements 3, 4. That's why that's because the logic is the following: an empty array is always less than a non-empty array, and in a non-empty array we choose the minimal element, and the minimal element will be used for sorting. So from what we can remember, okay, an empty array is always less than a non-empty array, and then we order them by natural order of minimal element of the array. Now let's say we want to implement find command because querying is another important thing for each database. So we want to find all the elements that are less than 2. Again, we remember that v is an array, so we want to search in such an array. Maybe we expect something like this. We expect to have an empty array, and then we expect to have an array with elements 1, 2. So in fact, how find works. In each array, we need to find an element that fits our query. And our query was v is less than 2. So we need to find elements that are less than 2. In this case, it's only one element. It's an array with elements 1, 2. But from the previous result, from our sorting results, we know that an empty array is always less than a non-empty array. So personally, I would expect this to be results of the query v is less than 2. Let's run the query. In real life, we see that only the second element was found, the element with the document with elements 1, 2. So what it means for us? From sorting, we know that an empty array is less than a non-empty array. From filtering, we know that an array of elements 1, 2 is less than 2. But when we filter, an empty array is not less than 2. That's an interesting logic. So it means that if you already implemented some logic to order data for sort, we cannot reuse it for filter because the logic is very different. That's only one example. We have many other challenges. Luckily, we also have community. We are open source, so we have contributors who help us solve some challenges. And yeah, if some of those challenges are interesting to you, you are very welcome to join us and try something some of those things. So what happened in our case? When we came up with an idea how to store the data, how to query the data, we thought 80% of work is done. The most important thing is to understand how to work with wire protocol, how to store data in the database that we chose, and what's in between. But in fact, compatibility challenges take another % of work. So that's probably our biggest learning about building such a database. However, I still invite you to join our journey, our adventure, and everyone can help us a lot. First of all, by trying FerretDB. Like, yeah, as I said, we are open source, so everyone can clone it, run it on your local machine, on your cloud solution, whatever you want. You can also start us on GitHub, because stars are really helpful. Our roadmap is public, so if you're curious what we are going to do, or if you have an idea what we should do, you can influence it. And actually, even our sprints are public, so if you're curious what exactly we do at the moment, there's also a way to look at it. We are open, and we are really seeking for feedback and questions, so please join our community. And I'm also ready to answer your questions right now. Thank you very much.
Cool. Thanks a lot, Elena. It was awesome. Do we have any questions?
Yep, there is one.
Yeah.
Hi, thank you. Very interesting product, very interesting talk. I have two questions. One is related to maybe overall, those other products are changing the license for the reason, and this reason is very well known. They don't want to be eaten by big, giant corporations like AWS and others. What are your thoughts on this? Do you think it will be the case if this is all very successful and in 3 years you will be changing license too? So yeah, obviously you should have thought about that. So we are interested to know these thoughts. And another question would be, I'm not sure, maybe I missed that. Have you mentioned something about performance compared to MongoDB? I know this is not the high reference to beat, but still, like, what's the comparison? Like, is it slower, faster, how much?
Thank you for the questions. So let me start from the questions about our license. No, we will not change our license. That's like our main purpose. So everything is built around the license. So the main purpose is to stay open source, is to offer an open source solution to like whoever needs it. So our license stays like this. Regarding my thoughts about the companies who changed their licenses, that's a tricky question. You know, like, on one hand, I understand and I really want to empathize with companies who have to do it because, like, really there are reasons why. On the other hand, when companies do it, the question is who are people who, or companies who will benefit from it, and who are people who will suffer, and companies again. So that's like not an easy question. If you want, we can discuss it maybe after the talk. And the last question was about performance. So yes, that's actually, if you look at our roadmap, you will see what performance is on the roadmap for, I think, next quarter. So because of those compatibility challenges, it was really hard to, first of all, become compatible. Like, I mean, we are not fully compatible still. We are compatible in some particular cases. Now I think we reached some like level of compatibility. Again, we try to ask our community what features they want to have and those things. And now I think we reached some expected level. And so now we are going to work on performance. And yeah, there are like plenty of things that we can do better. So our performance is worse than MongoDB performance, but we already have plans and like we know what to do with it. By basically just like pushing down more things to the backend, by like using some other things that can help us and such things.
Yeah, I have two small questions, I think. The slide with the BSON, isn't it internal implementation question why you had to implement that? Yeah, please.
Yeah, so maybe I can go back to that slide quickly. So yeah, MongoDB itself uses BSON to store the data, and we also needed something. So we knew that we don't want to come up with our own storage solution that can, for example, work with BSON. And BSON is a very specific format. So like, apart from MongoDB, I don't know who else uses BSON, maybe nobody. On the other hand, we know the databases who support JSON, including PostgreSQL. And in principle, I remember when PostgreSQL started supporting JSON, it was like, wow, we don't need MongoDB anymore. Now we can store everything in Postgres. So that's why like we decided to stick with like JSON approach. But again, JSON doesn't have all the features that BSON has. And so we had to come up with some way to basically offer those features. And that's why we came up with such an approach.
Yeah, thanks. Second one is maybe yes/no question. Like in MongoDB, you also have availability of managing your clusters. Is it a plan to support that features too in FerretDB?
Well, again, because FerretDB currently is just like a stateless proxy between drivers and Postgres and backend, if you know how to run your Postgres cluster, it's enough. You don't need any extra things. Probably we're going to tune something and introduce some features, based on the needs of customers or like people. So if you have an idea of what can help us, please share that idea with us.
Cool. Thanks a lot. I think that's it for.
Thank you so much.
Yeah, thank you. Thank you.